If you watched the last two videos, you will know the hoops I had to jump through to CNC the dividing head. I had to go ahead and make a mounting bracket and coupler adapter so I could drive the worm gear using a stepper motor. I then wired up the stepper motor using some borrowed stepper motor controllers from the CNC vertical axis. And I did all of that to hopefully cut a 57 tooth gear. Out of the box, these dividing heads can't make a 57 tooth gear. I could have made a 57 hole plate, but where's the fun in that? So let's go ahead and get that gear cut. I'll start off by cutting a blank out of some aluminium plate. I'll load it into the forge or chuck and I'll bore out a hole in the center. It needs to be pretty spot on 12mm, so I'll use a boring bar. And it nicely fits onto the gear cutting arbor that I made a while back. Now the old gear cutting arbor was really made for smaller gears, so I'll go ahead and make a bigger one to support the larger gear. I have a spare piece of 50mm diameter aluminium, and that should do the job. I'll face the end with the half center, and then I'll clean up the outside. I'll now turn up a 12mm spigot for the gear to push onto. And finally, I'll drill and tap the end for M6 so I can clamp the gear into place when I machine it. Next, I'll move the tool post riser block back about 20mm to make cutting the larger diameter blank a lot easier. You know, it really is one of the best things about having T-slots on the lathe. Now the diameter I'm aiming for is 59mm. For module gears, the outside diameter is the number of teeth times the module plus 2. So that's 57 times 1 plus 2. And I'll finish it off by breaking the edges. I'll now take the arbor and put it in the dividing head. I'll load up the gear cutting arbor with the correct number 7 cutter. The cutter has the correct involute profile for this number of teeth. I'll load the tool in the mill and I'll touch off the tool on the part and set the origin on the DRO. I'll move the tool in the cutting depth and I'll lock the slider. And the cutting depth here is 2.25 times the module. So that's 2.25 mil. At this point we should be good to go. I'll use Mark III to rotate the work 6.315 degrees, and that's approximately 360 divided by 57. And that's our nicely cut 57 tooth gear. Each tooth is actually pretty nicely spaced, and it actually looks better than what I can usually get doing it manually with the dividing plates and sector arms. I'm actually pretty happy with how it turned out. The final thing left to do is cut a keyway. Now there's many ways of doing it. You can use a filing machine or a file, and I've done that in the past, or you can use the lathe. This time round I used the method that I saw on ClickSpring's channel, and you just load up the tool holder with a horizontally mounted parting blade, and you use the carriage to push the blade and shear off metal from the work, akin to a shaping machine. The method does work, but it does put a bit of strain on the carriage. And well, those gears seem to work pretty nicely. Overall, it was a lot of time and effort to get this gear made, but I'm really happy. I had a lot of fun doing it, and I'm really happy with the setup. And that's about it for now. Thank you very much for watching, and I'll see you next time.